So, hello and welcome. Today we will be coding a code editor in Zig. If you don't know, Zig is a great programming language. It is a better C, and we can do all the kinds of cool stuff with it. Today we will be focusing on moving the cursor, yeah, let's begin. So first, I think let's see what we have right now. Right now we can read a file, display it. I think we cannot resize it yet, right? Oh, we can resize it. Beautiful, so we don't really need to do anything with it. Well, we still have to do something because we have to show the first line here, I think, when we resize. We want to show this line. But it will be done further. For now, let's just be happy that it doesn't crash like it did with new cursors. Alright, and we can also type some letters. Let's try typing. You see at the very top. We can write something hello world, but I will have to write it backwards, like world world and hello yeah, hello world. So we have it here. Now our cursor is at the very bottom. And as I understand, the terminal, this pseudo terminal, virtual terminal that we have, it has its own notion of a cursor, so it is in the state of this terminal. I'm a bit confused how we are going to implement multiple cursors. It's going to be something very interesting because so far I have no idea how to even approach it. But for now, with just a single cursor, it should be fairly straightforward. The terminal has some escape codes, they're called. Let's make it bigger. And there are some escape codes for moving. Yeah, move cursor up n lines, down n lines, right, left. Not sure why it says lines. Left corner. It should probably say columns, I think. Okay, let's see, maybe cursor. Are there any other? Yeah, okay, some other codes for the cursor. Oh, I think these are our needed codes. Cursor up and cursor up. Oh, okay, so it means that there are several codes that correspond to cursor motion. They're not very different, right? They're just A with a parameter. This is how a parameter is applied to an escape code. We first write the arguments and only then we write like a function name. Okay, so let's go with these for now. They seem kind of simple and straightforward. So what we should do? Well, first thing is that we will have a model editor, and it means that it can have several modes. For example, the Cocoon editor, which I am using now, is a model editor too, and now when I press J, it moves the cursor up, down, right, left. This is what I want to implement, but at the same time it has an insert mode. For example, if I press I, it enters an insert mode, and now when I do same things, it types letters straight to the screen. for now we don't have a special place for the current mode, so let's just make a global variable here. Var mode, maybe current mode. I usually like to be more explicit. I don't like the heritage of the C language where every byte is so precious that names are maybe several symbols. Okay. Okay, let's say that we have current mode, maybe even a boolean for now. Right? Current mode is insert, and we will have it false as a default value. Okay, so we have our global mode variable. And now we have this event dispatcher, which is supposed to look at all the possible events and determine which action to do, depending on the event. It also has this kind of, I think that this recursion is a nice approach, that we have a key press which dispatches another event, insert character event, and actually this insert character event is going to do the right thing to insert this in the terminal. So this is where we should do our if-else branch with the mode. So let's use this condition for now. It's just a debug condition. I use a just self-written code to parse the keys which are pressed. In terminal it is extra interesting, I can say. Let's write if current mode is insert. So if we're in the insert mode, we do this. What we have for now, we just insert, we just send a new event for the dispatch, and it inserts a character. For now we don't even specify where. It's just an 100 offset, means at the position of 100 it will insert a character. And else, let's see. So now we can switch on the value that we get. Well, dot UTF-8 first, and we will just switch. If it is H, we move left, so far we don't have a special place to keep all our commands that we can actually perform. This event dispatcher thing, I think, should be responsible only for the events, but for comments we should also have something similar. I did not yet create a structure for this, so we should go with something like, I guess it should be move, right? It would go like, maybe we can have a general move function somewhere. Yeah, let's just draft a function to move bfn move cursor. Okay, so we have this somewhere. It is in the UI. So we have in the UI we have a function move cursor, which just takes row, column, and moves it there. Although I'm not sure, does it take like an absolute row or relative to the upper left corner of the screen? Well, we will see. Okay, so we can use this function, I believe, or not. Wait, can we use this function? Let's try to see, is this going to compile? Like so void and just do nothing. So are you going to compile? Sweet. Okay, we can do that. Just print this one. So character sequence longer than 1 byte, and we can type unknown. Oh, okay, let me do it carefully. Unknown, yeah. Command, and we want to see a character, the very first character. Okay. Can you compile? Okay, so we can compile, we can use this function name. I was a bit worried about the collisions. Okay, so move cursor. This function should take a UI, I believe, for it to tell the terminal screen to actually move. Then it should take a direction, I believe. Some kind of const move direction, like so. And it will be up, down, left, right. And we can also have some special things in here, like move to the beginning of a line, move to the end of a line. But for now, I think we can live without them. Direction, move direction, and a number, right? A modifier that will supply when we want to move several places at a time, like just number, right? Direction number, or like a quantity. Okay, let it be just number, and we will use U32. Okay, so now we will tell the UI to move the mouse. Oh, sorry, move the cursor. Tell the UI move cursor, and do we use same things here? Maybe it's just a function from the UI module, like so. Maybe move direction, I don't know where it should be, so maybe we can keep it at top level for a while. And this we just put inside the UI. Okay, it takes self, and okay, so now this is a UI and abstraction, like a general UI. The idea is that we can have several user interfaces, and for now we have a single backend. I just like terminals, so I started with this backend, and maybe this backend can provide us some functions about moving maybe right, left, up, bottom. Okay, so I think this should live in here. It is closely related to this function. And since we have separate codes for our backend to implement, they will be separate. We should have a switch in the UI abstraction, I believe. Or let me think, we should also consider that it can be used in other backends, and it also makes sense to do this switch case in the UI backend as well. Maybe let's do it a bit simpler. It's not really simpler, I think, but at least it makes sense to me. And we just pass a direction and a number. And also a try, I believe. Yeah. Okay, so now since we just forward it to the backend, I think this UI should be abstract, and moving a cursor is not does not entail any specific actions you should take. So mod2 3 bar says UI should only handle move cursor event, and the keyboard get the inputs. Move cursor and the keyboard. This is also a bit, I think the keyboard should get the input. This is correct, but we have these keys, which I suppose should be something like parsing. We will parse the keys, I mean not parse, but it is a structure for the keys. But since key parsing is very backend specific, for example, here, let me show you, it should be somewhere here, next key function, next key. For example, here we get the next byte from standard input, and here in the next key we also account for some codes. For example, 3 is when you press Ctrl+C, so we construct a key like Ctrl+C, and otherwise we just pass an ASCII symbol. So since the key handling, like getting the key, is very backend specific, it lives for now here. Keyboard Z get inputs. I think I answered this question, that since it is backend specific, I would like to keep it in the UI part, like a UI backend. I believe in frameworks like SDL, GTK, this can be very different, because terminals is like a real very separate beast, like off and in itself. There is, let me show you maybe this. There is a Cocoon terminal editor, and which I use. Actually, this one is in Cocoon editor, and it has some key parsing. This is key parsing. And it's like maybe 400 lines long, and there is RxVT style, Tmax style, and there are some Kitty specific parsing for Kitty terminal. It's just wild west of terminals. They don't have one real standard. They have like ANSI standard, but they differ in very different things, and in future we will have to account for them. Okay, so we were moving the cursor. So since we want same function signature, I believe the correct pronunciation, we can just put it at the very bottom, maybe a little bit higher since it is a public function. Pub fn move cursor. So we take self. I'm not sure if we need to change our state as... the state changes, but do we record it somewhere? Well, at least we do we eat some input or output stream? Okay, let's try without a star, without a pointer, and if we need, we will just add it. And now move direction. Let's make it global for now. And where were we? Here. Now we will switch. Okay, valig O says it's not less. I believe GUI world is also wild. I'm very cautious about GUI stuff. I know it's very hard. For example, I saw like so many things Rust tries to say, like a new blog post, or it's a new UI, and maybe for 5 years new UI, like a shock in use, like that. Really funny. I guess it's really hard to do. Okay, if we get up, is this how we write? Up, then we just print to the stream. We get our self raw writer. Raw writer just writes without any escaping to the output, to the standard output, right? Yeah, we have some implementation of buffered style, so we don't have to redraw all this stuff like character by character, but just throw it all in the buffer and render it once, so we have some performance and avoid flickering. And we have a writer for like it auto inserts this carriage return, so that it is expected behavior when we want to put something. And raw writer is just for escape sequences mainly. Okay, Valigo says, and I think handling inputs in terms of UI implementation might be a good choice if you consider UI implementation as a separate platform that you support. Yeah, I fully agree with that. In my implementation, I'm trying to make a modular design so that we can have separate front ends for a single backend, kind of Xi or Xi. Yeah, I probably know this editor. Is this somewhere here? It's in overview. Yeah, this editor. It was a very hyped editor. I saw the author, or maybe author of the project, on the conferences talking about it, and it has some good documentation, thoughts about how it was designed, and one of its ideas also was separate backends. Raw, right all. Okay, so yeah, maybe we just can do it in a private function as well. Why else nothing? So we have here some function move cursor. So it is a move cursor like at any position. Yeah, we move it to the very beginning before we clear the screen, or I mean after we clear the screen, so we can write something more. And now let's just move cursor up, self, and number year 32, void try self writer, and we print. If we have a number, we print 1. If we don't have, we don't print it. Or we can just print it as well, right? We can print here the number. There's that. Yeah, we can just print 1 in any case. Okay, so this is a bit different still, because it's not actually CSI as I understand, because it lacks the second left square bracket. So this is CSI, sequence control introducer. We probably want to go always with CSI. As I understand, it is a widely adopted standard. Let's console codes, cursor, escape 7, okay, and so yeah, in ECMA 84, in ECMA 48, which is a widely adopted standard, there are some keys, and it requires a CSI, which means okay, I'll just do it here. So we do print Now we put CSI, our control sequence introduce. It is, yeah, it's just these bytes. First one is escape when you press escape, and square bracket. Then we go with CSI, then square bracket, then the number, and for up we do cursor up A. Yeah, we do A here. Okay, move cursor up, and here we write move cursor up. Okay, let me make sure that we move the cursor up actually. Where that H, no, it should be K for up, and we do self UI. Yeah, we can dispatch, but let's for now not create a new event and just do it the simplest way. No, self UI move cursor. Okay, language server error. That's not good, but we can handle that. So direction and number. Direction up, dot up, and number 1. Okay, Veligo says, yeah, it was hyped a lot, but died under its own complexity. Yeah, it's about the Xi editor. Yeah, I understand. It had some good outcomes though, so it didn't die for nothing. Yeah, I also really liked reading about the documentation and different stuff. Like very good rope science, how to use rope architecture. I kind of want to do a same thing, but without crazy async stuff. I believe that if I'll try to do it with asynchronous input-output server-client communication, it will just become 10 times harder, and I don't think I'm that good yet. Okay, so when we press K and it is false, we should see that our cursor moves up. Okay, let's try to compile it. All right. So 5, 3, 4. Okay, move cursor, direction, number. Okay, now 103. Self UI. So we don't have a UI, do we? Well, why don't we have a? How do we even do it? Self text buffer, display windows, and do we do something in the UI? Yeah, I believe we have it in display window. Okay, let's not introduce a new coupling and just reuse this one here. And then we have not all possibilities, looks like. This is large. Redefinition of move cursor. Okay, 5, 6, 7. Move cursor up. And where do we have it? 5, 3, 1. Okay, well, I kind of want to Oh, I see. It is same backend, so it's not so far away. We have it here and also here. So how do we call it? This is move cursor, which is strictly like this line here. So it makes total sense to name this low-level handling function like move cursor. But this one, move cursor to. Okay, maybe we can fall back to the C style, move cursor. Doesn't sound very good. Maybe. Okay, naming is like the hardest part of programming, I think. I spend so much time on it, but usually it pays off, especially when team members agree on this part. Yeah, unusable macro abbreviations go brrr. Move cursor. Maybe we can add something here. Okay, we have move cursor, which is a low-level function, and we can have like erase display, and okay, I don't know for now. Let's try just to come up with it later. Move cursor to, a perfectly valid name. We will need to redefine it just in one place here. Maybe later I will have a nice idea. Try catch, yeah, of course, we can use that. Try. And then 54. Use of undeclared identifier UI. Self UI, I believe. Okay, self backend. And direction found move direction. Move cursor up. Yeah, 534. Direction number. And what's up with that? Self number. Oh, I see. We already dispatched on the direction. Okay, our compiler tries really hard for us to not mess up. Found const. Okay, so it means we need a star. Okay, 534, what did we forget? Error is ignored, okay. Okay, moment of truth, I press K. Nothing happens, oh, we'll have to debug that. Okay, so debugging is also a bit hard because I actually don't know how to debug properly, because this in here it takes standard output. So when I try to output something to standard error, it also sends it kind of here, but it is not shown here, so I have no idea. And usually it prints something at the very end when this program stops. When I stop it with std os exit, then it prints from the standard error. I guess it just flashes first standard output, which is this, and then standard error. But how to debug it live? No idea. Also, LLDB doesn't work here. I didn't manage to make it work. I guess there are some introductions how to make it, because new cursors use the same kind of idea, and I believe it's pretty popular. Maybe we can find something, but I didn't try to find it yet. Okay, so why it doesn't print? Let's go to the call sites and see where does it even go. Do we even get our event dispatcher to catch this event? Okay, we can just mess up with our code and press set random, maybe std os exit 1. Maybe unreachable even. Yeah. Okay, do we reach unreachable when we press K? Beautiful. Okay, next one. Move cursor. Do we reach here? And perfect. Okay, let's go next. What about here? Do we reach this one? Unreachable. And press K. Perfect. Now move cursor up. Do we reach here? Perfect, we reach here. Now, what can we do? We can debug it, I guess, from the terminal, from here. We can just try, I guess. We have, this is CSI sequence, this is bracket, number, and A. CSI, bracket, number, and A. Okay, what if we use it without the number? Let's create a move cursor up to, and we will just use this code cursor from here without CSI, just just without CSI, it's just escapes character. What about this one? Cursor up to, and we don't need a number here, and here we use move cursor up to, and nothing here. Save. All right, let's go. Okay. Oh, unused this new Z compiler which manages all the unused stuff. Sometimes it's a pain. And 531. So how do we deal with that? Move cursor to. Okay, let's move cursor 3, beautiful, without the number, and here, and here, and here we have move cursor 2, without the number, and here we use move cursor 2, without the number. Expected 3, found 2. Oh my gosh, expected 3, found 2. Yeah, I'm not sure I can, because of this all the structure that I made. I tried to design this beforehand, so that I have a clearer vision of what's going to be next and how to separate each modules. And this is what I get in return. Expected 3 arguments, found 2. Move cursor 3. K doesn't work. Okay, maybe we can do some other stuff. If it didn't work, let's revert it back. Yep. Here. And now okay, so good. Let's think, how can we debug it? Well, we have this move cursor function. How about we try to use that? Maybe we can get an insight of what's going on. Let's right after that we will use this function, and I believe we have it used already somewhere. And yeah, in the clear function. I guess there is some interaction that it does automatically, and I'm not fully aware of it. Maybe we can instead just try to follow the kind of stack trace of the program, how it processes events, right? So here we get our while loop, which sleeps for some time and tries to get a key. Then if it is a Unicode code point, for now it is just ASCII symbols. We stop on Control-C. Does it still work? Yep, it works. And else we do an event dispatch, and we dispatch our event, and we don't do anything else. Okay, let's go here. So we dispatch an event. It is a key press. Now we should move to this branch, and we did confirm that it is executed because we placed here unreachable statement. Then this move cursor is here. We just forward it to the backend, and backend forwards it here. So stack trace is pretty clean. This is a problem because it would be much easier if we found some error here. Okay, let's try that one. Move cursor self dot move cursor, and we say row maybe 15 and column 1. Let's press K. Yeah, still nothing happens. Do we have some extra input? For example, if we do like so, and now we run it. So, oh, I see. So we kind of we just clear the screen, right? If we write a lot of no. Okay, I thought that we did some things like copying it all over and over again so that we don't see it. Let's use shorter lines so that we don't have all the screen filled with this thing. I have here long lines. Okay, when we press K, nothing happens. Still nothing. Okay, this might be harder than I thought. Maybe we can get some insight from here. So this is Cocoon source code. Maybe we can have some insight how it does its things. Maybe by searching for a bracket. And yeah, maybe we can just search for A. This is not a very often character, I believe. We should find some printf statement where we print this in a code to move the cursor. Okay, so we didn't do that. Let's then try searching a bit more for cursor leftwards and up. Move the cursor. Maybe we just got the wrong control codes for that. This is C0 controls. Does it have CSI? No, I don't think so. Okay, maybe here. Okay, we actually know that the sequence should be correct because we got it from here. Move cursor up the indicated number of rows of columns. Okay, it means that I don't have a clear understanding of how the terminal operates the cursor state. I think I will have to do some research on it and try to understand why it doesn't work somewhere offline, because I don't seem to be getting any progress at this point. Okay, so apparently moving cursor is a hard thing to do. Okay, so maybe we can just commit that as a to-do item. Yeah, we can just change the mode here to true, so we can type some letters. Let's try it. Okay, yeah, we can type something. Beautiful. Okay, let's commit that with a to do. We need to try to figure, maybe not a commit, right? Maybe a git stash, but no, since I'm the only one who can contribute, I just can control it, no matter. Try to figure out why the cursor doesn't move. Okay, I believe it has something to do with how we do the render. Yeah, maybe it doesn't want to interact with it somehow, or there is also some black magic here with all these settings. Yeah, maybe I'm just doing something wrong here. These are for very old terminals, which were kind of hardware terminals. And here you just put some flags and hope for the best. This is the best set of flags I could find. Let's try to do one more thing. Let's try to do this thing. So here, when we run our text, our cursor is at the very bottom. And I would like it to be at the very top here at 1. Yeah, I want this cursor to be here at 1. And to do so, we will try to do this thing. We will hide our cursor, then we will draw everything we have, then we will show our cursor, and it can be here on the first line because it was hidden when it was printing. So let's hope for the best. Let's try to do that. So how about show and hide? It is with a question mark, I believe. Yeah, here. Default on, make cursor visible with escape right bracket question mark 25h, and h I believe is for high, because in order to it is enable, and in order to disable you need to pass L, which is like low. Well, it is my intuition at least. Let's try just add these functions first. Fn hide cursor self, and we don't need to pass any parameters. Raw writer dot write all prints. We still need the CSI here, and we go with question mark 25 L for hiding, question mark 25 L. Okay, CSI, and Valigo says, why are you hiding show the cursor instead of moving it to 0, 0? There is just for flickering, I guess. I'm not sure how the terminal operates its state of the cursor. So if I hide it and I print something, does the cursor move? I have no idea. No, you understood it correctly. I just don't have a clear understanding of how the cursor works. My suggestion is that if we hide it, print it, and show it, maybe it will be at the same place. I doubt so, but let's try that. This is for hide and this is for show. It's also for reducing the flickering. When we have a cursor and it prints a lot and the terminal speed the speed of printing the characters is slow, we will see a moving cursor that will print when something prints, the cursor is at the very end, so it like appends, and we will see a cursor moving like line by line printing something. And when it is not slow but not also fast, we'll have this flickering effect where we see some like maybe 4 frames of cursor in different places. So it's just for avoiding the flickering in the first place. But we will also know some internals how it works, whether our cursor will be at the very end or at the very beginning of the string. Okay, so HeightCursor and ShowCursor. Okay, and we can just use it here. Yeah, I believe we can just do it like so. Backend HeightCursor and defer try self. No, we can't try with defer. Is this correct? Yeah. Maybe we can just do it at the very end. Try self backend show cursor. Okay, Valigo says, oh, understandable. Imagine supporting anything slower than Alacrity. Well, yeah, current terminals like super fast, and we probably wouldn't see this flickering. But it can also depend on other factors like SSH. Yeah, if you do something through SSH, this so-called baud rate is quite slow. Okay. Okay, we have some troubles. Redefinition of HeightCursor 578. Okay, I just did it 2 times. Okay. HeightCursor, let's try to compile it. Okay, so we will hope that something worked. It doesn't seem like so, but we added something. We can still compile it. Let's commit it. Hide and show cursor between rendering. Okay. Matuspa says what is more responsive for pass screen uptime, so depends on the metrics. Updates. For updates uptimes, so depends on the metric. What do you mean by food? I'm not sure I understand. Maybe it is also some autocorrect thingy on this Mac stuff, I believe. On my Mac, I have an iPad Mini. It also autocorrects all the technical words I'm trying to write, so I just gave up and I don't use it for writing, just watching. I think this one. Oh, okay, let's see. Copy link. Is this legal? Yeah, it seems legal. A fast Wayland terminal emulator. Okay. So it is a Wayland emulator. Okay, I believe I can try that. When I go to Wayland, I haven't heard of it before. But it's almost like 4,500 commits. I guess people put some work in it. Okay, so we just committed our showing and hiding cursor. Now let's move it to the very beginning. There are two possible solutions. There are codes for saving. No, it's a report. There is also save cursor position and restore. Yeah, here. we have save cursor location and restore cursor location. This is how we would want to do it when we do actual rendering, because we want to save it, we want to hide it, we want to render all this in, and we want the cursor to be in the same place where it was before. But we should also solve our mystery with this function. Can we actually move it to the very first position at the end of the render function, right? So let's go to render. I believe we, in clear, we do that. Yeah, let's go here, just copy, erase display, move cursor, refresh. Well, thinking about it, I think we forgot to refresh. Yeah, this is why the cursor doesn't move. Yeah, I believe so. Well, we have, this needs a bit of explaining, right? We have this raw unbuffered writer, which is just you write something and outputs directly. Then we have raw buffered writer, so that now when we write, we always have a buffer and we write to this buffer, and only when this buffer is overfilled, like 4 kilobytes, I think, or when we say directly flush your content to the output, it writes something. I believe this is the problem. We just didn't say to flush the content. This is why the cursor didn't move. Okay, the mystery is solved. So let's first still move the cursor at the very first position. We say refresh. Yeah, we say show cursor before refresh, because all these commands, they kind of seem like you say and it does something, but it actually outputs something to the buffer. So we really need to flush it out in order to perform a command. Now let's try self backend, move cursor. We want to, why does it show me like here it shows for show cursor? No, we need move cursor. And not direction, but with absolute position. Yeah, just 1 1. Okay. Move cursor 1 1. Okay, and all right, we have something. So here we have our it is high, so it is show cursor. We are doing something wrong, but still. Okay, Velga says, I mean, 100 stars on Codeberg is a lot. Yeah, I believe so, on Codeberg. And for something as niche as native Wayland stuff. Well, you know, native Wayland stuff was niche maybe 5-6 years ago, I believe. Now it's kind of this hipster thing, right? New kids love Wayland because it's something new, not 50 years of Xorg legacy and heritage. So new kids kind of like new stuff, and I believe I'm also a new kid because I also used Wayland. It has this bug that I couldn't really refresh, share the screen, like full screen, and I had problems with that. Yeah, I had problems with that, and I really needed it for my work, so I switched to Xorg, and this one is W3M, right? This is how it's called. Oh, it's W3M. I think W3M is a browser, actually. Okay, I believe you know. It's like I3M, yeah, like IVM. I guess I can't, sorry. Yeah, last couple of years really hyped, I agree with that. HeightCursor, ShowCursor. Why? So what's wrong with that? Why do you print this stuff? Okay, maybe we are doing something a bit wrong. Escape bracket question mark 25h. So everything seems fine. Maybe we can do like so, and so now it's here. So I didn't manage to, at least I managed to move the cursor at the very first position, I believe. So okay, maybe what if we just don't do that? Does it really hide the cursor? Because we tell it to hide the cursor. Yeah, it doesn't even hide the cursor. Maybe this clear stuff is a bit wrong. We do erase display, move cursor, refresh. Maybe we should do it like so. Let's try. Okay, so now at least it shows us 25L. Why? What does refresh do? Says Veligo. Refresh, let's see what it does. fn refresh. We say self buffered writer ctx flush. So we flush all the buffer content, we flush it to the output. So this is our way of saying, okay, we have written enough data to the buffer, now it's time to display it on the screen. Something like that. Okay, let's try to write them one by one. Does it have any effect? Okay, so we have it here. Yeah, maybe I'm doing something wrong because escape does maybe, no, it still says escape. Oh, maybe I guess I understand. Yeah, I'm putting an extra this symbol. It says escape and right bracket, left bracket. This is very easy to mess up, right? This one is CSI, right? Let me show you. Const CSI, yeah? Here this is CSI. This byte is an escape byte, so it is here. And this is left bracket, which is also part of CSI. And it says CSI and then just this command. But we put an extra left bracket where we shouldn't do that. So one here and one here. Okay, let's try that again. Okay, seems okay. So now we like so, yeah, like so. We hide cursor, then we clear all the screen, then we do our rendering stuff, we move cursor again to the very first position, and we show it. Let's try. Okay, seems working fine. Seems fine. Let's add commit, show, maybe hide, or what did we do actually? We already did a commit on show and hiding. Yeah, maybe just fix CSI, not CSI, just fix commands for ShowHide. Yeah, good enough. Velaga says, so you render to some kind of a back buffer first. Yeah, yes, that is correct. I think maybe in the future, like for those maybe slow terminals like SSH, new cursors, a popular library for this TUI stuff of what I'm trying to do, it does a technique which it calls double buffering or double rendering. So the idea is that they have like first buffer and a second buffer, and when they do rendering, they try to understand which sequences they need to send, minimal amount of sequences. So they diff first buffer with the second. So do you see my hands? Yeah, maybe I should show it here because the camera is very small. So two buffers, yeah, if you're familiar with web development, it is basically what React does, diffing algorithm. Or it is, I believe it is also similar for SDL, you know, this OpenGL stuff, graphics stuff, same idea about this double buffering technique. Okay, do I still have internet? Yeah, I just have bad connection sometimes, and my sequences are broken. Let's just recreate the terminal. Kisa, and yeah, a little bit bigger, and maybe a little bit more bigger. Okay, so now let's finish our quest on moving the cursor up. So what we need to do is put here, else we do something, and we do refresh. Self, yeah, this here. We just do a refresh instead of anything else. Refresh. Okay, here we set it to false, and the moment of truth. Okay, so now let's just refresh instruct UI. Okay, maybe we can do it inside the move cursor. It also makes sense. Try self backend refresh. Let's go. And okay, we are at the very top, so moving up just inserts an A symbol. Well, it's better than nothing. It's better than previous attempts, at least. 1A. So I guess we just didn't do the sequence correctly again. Maybe a left bracket is missing or something. Yeah, Veliga says, yeah, double buffering is basically what everyone apart from X11 are doing. In Wayland, it's even a part of the protocol, if I recall correctly. I bet on an extra bracket. Yeah, extra bracket. About Wayland, I'm not sure. I heard that in Wayland they use this kind of direct rendering, where they have just a specific memory region, they modify it and it goes to the screen. So I'm not sure how you would efficiently implement double buffering if you have direct memory access. Well, actually, yeah, there are some ways. It's not really like that technical to implement it. Yeah, I guess yeah. It also makes sense to do it in a new like technology, because it's fun to implement some complex technologies, even if it doesn't matter on the modern computers. You can always say, it's for the old things which run slowly. But it's also really fun. For example, for now here in my editor, I have this text buffer. And it's not a gap buffer, it's not a piece table, it's not a rope. Yeah, just three most popular backend data structures that are used for the buffers. I just have a simple, where it is? Yeah, here. Simple std array list, array of bytes, and I just move everything one character forward when I insert something in the middle. Yeah, just most silly, stupid technique. Okay, let's find our extra character, and maybe let's do it with move cursor down, because we want to actually see the effect and not see another stack trace. Let's implement down, and let's here we just forward move cursor. Yeah, we just forward direction. So we need event dispatcher, and we need to copy this. So down is J, letter J. Okay, now let's try to modify this down command. Move cursor down. So move cursor down to column 1. No, just down. Move cursor down indicated number of rows. Okay, B. Okay, B. B, and action of a CSI sequence by its final character. So we have here CSI, escape, and left bracket. So our escape, don't need that bracket here, don't need that bracket here, number and letter B. Okay. Let's see. J, nothing happens. K, nothing happens. Okay, it is a bit worse than previous time, but maybe there is a good reason. Do we refresh? Let's see. Do we do refresh? Move cursor. So we don't refresh here, but do we refresh here? Yes, we do refresh here. Okay, maybe. So what else could be wrong? What else could be wrong? It also could be this sequence. Maybe we're not doing it correctly, but at this point, I believe we do everything we want. Okay, set keyboard. Let me read this a bit. Maybe there is some truth we need to understand. Okay, so it doesn't say anything particularly interesting for us. The action. Okay, so we are kind of making progress. We say move key. Maybe what could else be wrong? Let's try with our src main. Okay, so nothing here too. Okay. A riddle for Jacques Fresco, I believe. Move cursor down. Maybe this somehow contributed to our failure. Oh, beautiful. Do you see it? Let's make it on this file. Yeah, let's make it history. Oh, so great, great. We can move up and down. And really anywhere. Not even bothering. There are lines, no lines. Yeah, let's add left and right. I believe this is logical continuation. So we have A, B, C. What's C? C is right. Okay, let's do right. And left is going to be D, I believe. Yeah, it's D. A, B, C, D. Okay, let's go to our dispatch. We don't need else here. We just copy that and we go right, here right, and here left. Left or right, up, down, right, left. Let's modify our dispatcher. Yeah, here. And we go, so right is going to be L. And left is going to be H. Okay, let's play a bit. Yeah, we can move the cursor up, down, left, right. Alright, that's great. Beautiful. And yeah, let's commit this. Cursor moves up, down, right, left. Great. And let's do one more thing. I would like to change the mode to insert. So on I we get to insert mode, and on not escape, maybe on Q for now, because I'm not sure how to, I don't know how to parse escape correctly. There are some difficulties with the escape key, because escape byte, yeah, you saw that here in const CSI, yeah, here. Yeah, this one is actually a byte which is sent when you press an escape key. So an escape key is kind of crucial in a number of ways. For example, it sends some controlling code to the terminal with the CSI. So for example, when we press escape key, we should also wait, is there a left square bracket? If yes, this is CSI code. Or if there, in the lib term key, which is a Vim library for handling keys, it says like so. Because this byte, and if you get like A, right, this can be two possibilities how this can happen. First one, when you press escape and you press A. Yeah, you press escape and you get this A. Second is when you press Alt A. When you press Alt A, it actually encodes it like so. Yeah, I think I can actually show that scene. Run, yeah. So I have here a little program. When you press a key, it says the bytes. Yeah. So we have here this one. Yeah. Now I pressed Control L, C. Okay, let's just get A. This is A. This is escape. And this is Alt A. Yeah, you see it's like this is A, this is escape, this is Alt A. So kind of weird, right? So this is a problem we'll have to deal with, but a bit later. For now, let's just implement it with Q. Okay. Key press, and we get to this branch. If current mode is insert, we dispatch insert character, or if val dot utf-80 is Q, we say current mode is insert, no more, else like so. And same stuff here. When we press I, we want to enter insert mode. We say insert mode is true. Okay, let's test that. Okay, so we already got some strange stuff which wasn't here before. Did we mess up something? Git stash to just try it with. So okay, so it means that we did something which we shouldn't do right here, which should be fine. Let's make it a bit smaller. So we added here. Ah, I see, I changed it here and forgot to change it back. 441. Yep, like so. Okay, and we can move around. Now when we press I, we entered insert mode and we can type some characters. Yeah, fine. We don't care about where they are typed and that our cursor is moved at the very first position. It's just temporary. And we press Q and we can move our cursor again. Beautiful. So yeah, let's commute that. Going in and out of insert mode. All right. Yeah, that's scuffed. Scuffed. I'm not sure what scuffed means. Let me translate it, or maybe trans, and maybe meaning. We can say n scuffed. Scrape or brush the surface against something. Oh, like scratched, like rough. Okay. All right. So I believe we can stop with that. We did some progress, and I usually try to keep things I do on video scoped, and for now I believe we reached some a good point. I think in the future I would like to do maybe handling this mode a bit better, so that we can use escape to quit like in other popular model editors. Then we can probably, yeah, I think it is it. And I will also need to research, I'm currently researching some client-server architecture, how we can implement that. Basically, I want this main function to launch a server process and currently be on the client process, so it needs some fork, some Linux stuff. I'm currently reading about that, and I will hope to implement it soon. And we will also need some more clear separation between server and the client. But for now, I believe this is kind of decent API surface, so we can start abstracting it into different layers. Maybe we should add something else. So the idea behind that is that we want to have some API surface covered, like not covered, maybe we need to have some API surface which we use, so we understand what we actually need to do with our things. And once we know that, we can have some abstractions which have meaning, because without actual use case, we won't be able to understand how we want to abstract things. And why I want to abstract it in the first place, because it's just easier to build on top of that. For example, here I have like 646 lines, and I believe all of this can be done in maybe 200, 300 lines without all this extra stuff. But it will be very useful in the future, because we already very strictly follow the API boundaries between different objects, and we know what they know, what they can manage, and so on and so forth. Well, it's pretty basic stuff, like I believe it's no magic. We just try to do things naturally, but a little bit more on the design side. So yeah. Okay, so I believe we can end here now. Thank you for everyone who was there, and have a good day. Okay, bye.